Hi, hello and welcome to BK's Tech Stack. I am BK. Today, we're diving deep into the fascinating world of data science with Python, specifically focusing on statistical analysis and its business applications. This course is designed to equip you with the fundamental statistical knowledge crucial for any data professional. Before we delve into the specifics, let's outline what we'll explore today. We'll start by clearly differentiating between statistical and non-statistical analysis, laying the groundwork for why a data-driven approach is paramount. Then we'll dissect the two major categories of statistical analysis, descriptive and inferential statistics, understanding their unique applications and how they complement each other. We will also walk through the systematic process of conducting a statistical analysis, ensuring you grasp the logical flow from problem definition to drawing conclusions. Finally, we'll spend significant time on understanding data distributions, calculating measures of central tendency like mean, median, mode, and percentiles, and interpreting the spread of data. These are foundational concepts you'll use constantly in your data science journey.
Let's begin with a fundamental question. What exactly is statistics? At its core, statistics is the science of data. It encompasses the entire life cycle of data, from its careful collection and rigorous analysis to its insightful interpretation, clear presentation, and systematic organization. Think of it as a powerful bridge that connects raw, often complex, real-world problems to actionable, well-informed decisions. Without statistics, we'd be navigating data blindly. We leverage various techniques, from foundational statistical principles and mathematical functions to sophisticated algorithms to extract meaningful patterns. These statistical tools are indispensable in data science, allowing us to deeply analyze raw data, construct robust statistical models, and critically forecast future trends and outcomes with a quantifiable degree of certainty. Now, it's crucial to understand the distinction between statistical and non-statistical analysis. Statistical analysis is inherently scientific. It's grounded in empirical data, relying on numbers, statistical values, and mathematical rigor. Its primary strength lies in its ability to provide a comprehensive and quantitative insight into the data, allowing us to measure, test, and validate hypotheses. On the other hand, non-statistical analysis often operates on generic, qualitative information, and by definition, excludes precise statistical or quantitative methods. While both approaches can provide results, it's the quantitative, statistical analysis that truly offers a profound and clearer picture. This is precisely why statistical analysis is not just beneficial, but absolutely indispensable for making informed, strategic decisions in any business context.
Next, let's explore the two major pillars of statistics, descriptive and inferential analytics. Descriptive analytics is all about organizing, summarizing, and presenting the main characteristics of your data. Think of it as painting a clear picture of what you have right in front of you. For instance, if you have the math scores of an entire class, descriptive statistics would involve calculating the average score, identifying the highest and lowest scores, or perhaps grouping them into low, medium, and high categories and counting how many fall into each. It's about describing your observed data. Inferential analytics, conversely, takes things a step further. It uses a smaller, representative sample of data to draw conclusions, make predictions, or infer characteristics about the larger population from which that sample was drawn. So instead of measuring every single person's height in a country, you might take a representative sample and use inferential methods to generalize about the average height of the entire population. This approach is particularly powerful and invaluable when it's simply not practical or possible to examine every single member of a population. Moving on to a cornerstone of inferential statistics, hypothesis testing. This is a powerful technique that allows us to make informed decisions about a population based on sample data. Essentially, we're testing a claim or an assumption. It always starts with two opposing statements, the null hypothesis, denoted as H0, and the alternative hypothesis, H1. The null hypothesis always states that there is no effect, no difference, or no relationship. For example, in a clinical trial, H0 might state that two medicines are equally effective. The alternative hypothesis, H1, is what we are trying to find evidence for. It states that there is an effect or a difference, such as the medicines are not equally effective. The process involves several key steps. First, clearly setting your null and alternative hypotheses. Second, defining a significance level, often denoted by alpha, which determines how much evidence we need to reject the null hypothesis. Third, collecting and analyzing your data. And finally, making a decision. The decision rule is critical. If your p-value, which is the probability of observing your data given that the null hypothesis is true, is less than your chosen alpha level, you reject the null hypothesis. Otherwise, you fail to reject it. This rigorous framework helps us avoid jumping to conclusions and ensures our inferences are statistically sound.
Thank you for watching. I hope you found this deep dive into statistical analysis with Python informative and engaging. If you enjoyed this video, please consider giving it a thumbs up, sharing it with your network, and of course, subscribing to BK'sTechStack for more valuable content on data science and artificial intelligence. Your support helps us create more content like this. See you in the next one.